Right, guys. If I had to pick one of the questions that comes up the most in an exam, it would be, I think, without a doubt, the question about how to plan an experimental investigation into a factor concerning enzymes. Now, I have made a video on this, but I think it was a bit kind of looking at general themes and not really spelling out step by step what were the things that had to be done. So we're just going to take a few minutes just to look at this. Now, in my previous videos in these series, we have spoken about factors that affect enzymes. We've spoken about cofactors. We've spoken about inhibitors in terms of the theory. Now, all those things can be tested with one experiment, essentially. Okay? Now, first thing, let's just talk about all the things that could affect an enzyme catalyzed reaction. So first, obviously, temperature. 2, concentration, either of the substrate or the enzyme. 3, we could have pH. 4, we could have a cofactor. Remember, that would be increasing the rate of a reaction if that enzyme needs it. And 5, we have inhibitors. And remember, there are 2 types, and they will give you different experimental results based on the type of inhibitor they are. Okay? Do we need to go over that again? Really? Okay. 1, temperature. Remember, increasing kinetic energy, increasing the collisions between substrates and enzyme, increasing the formation of the enzyme substrate complex, and so increasing product formation. I'll just put a P there, until the point when there's so much kinetic energy that it actually leads to the denaturation of the protein, and therefore the rate rapidly declines. 2, concentration effects. Okay, similar format of the thing. Here we've got temperature. Here we've got concentration. As we increase the concentration of either enzyme or substrate, the rate of reaction increases because there's more collisions, more likelihood of collisions between the enzyme and the substrate, therefore more likelihood of the enzyme substrate complex formation, until we reach a maximum rate where all the enzyme is saturated with substrate, and therefore there is no further increase in the rate of reaction, no further increase in the rate of enzyme substrate complex formation. Okay, so that's concentration right there. 3, pH. pH, remember, pH, there's an optimal pH for any enzyme. That's the pH at which the balance between the OH and the H is just right for that enzyme to have just the right tertiary structure to be able to be complementary to its substrate at the active site. But as we go away from that optimum pH, maybe there's too many OH ions, maybe there's too many H plus ions, in which case the tertiary structure is going to be affected, it changes, and so it might be less complementary to its substrate, and therefore there might be less enzyme substrate complex formation. If we go then to extremes of pH, we might get denaturation of the enzyme, in which case it's not just about no longer being complementary, it's no longer reversible, i.e. small changes away from the optimum pH are reversible. So if you put the pH back to the optimum, the enzyme will return to its shape again, and it will still be able to catalyze reactions. But if you go to extremes of pH, i.e. you go too far away from the optimum, then it might lead to permanent denaturation of the enzyme. Now, so that's what we've just talked about here. Okay, here is the optimum pH. right here. And as you go away from the optimum pH, i.e. increase the pH, more OH ions, it leads to a change in the shape of the enzyme, so it might no longer be complementary to the substrate. Less enzyme-substrate complex formation. The thing you have to remember is that this might not be straightforward. Some enzymes might have a pH, an optimum pH, which is very acidic. Okay? And other enzymes might have an optimum pH which is very alkaline. Right? So please bear this in mind. Different enzymes will have different optimum pHs. It's not just about an equal balance of OH and H, i.e. acidity and alkalinity. It's about each enzyme having its own preference for that pH. Okay? So that's pH. Remember cofactor, so if that's our regular enzyme like that, a cofactor might do this. Alright, so it's going to increase the rate of that reaction. And 5, that's product formation, that's plus cofactor, and that's minus cofactor. And 5, we're going to have our inhibitors. So that's just the enzyme on its own, no inhibitor. And that is competitive inhibitor. Where's my blue pen? Come on. And non-competitive inhibitor, remember, okay, is not affected by the substrate concentration. Okay, right, so that covers that, okay, enjoy. Now what we're going to talk about is essentially how do we get these graphs, right? How do we carry out the experiment that gives us this graph, that shows us the effect of temperature on the rate of product formation? How do we carry out an experiment that tells us whether something can act as a cofactor? How do we do the experiment that tells us if our inhibitor is a competitive or a non-competitive inhibitor? All right, there are very few basic things you can say to get good marks on a question like this. All right, and we're going to look at that next. Okay, so here we go then. How do we do an experiment? Basic things. All right, so in each case, you will have to ultimately mix enzyme, and unless you're looking at the effect of enzyme concentration, usually you'll always have enzyme concentration constant. So you'll mix enzyme and substrate. 2, you will keep enzyme concentration constant, the same. Remember, unless you are actually investigating different enzyme concentrations, you keep enzyme concentration the same, all right? And let's just say, for example, we are investigating the effect of substrate concentration. In that case, we will have a range of substrate concentrations. Sorry, this is how I say concentrations, okay? Just to save time. So we'll keep enzyme concentration constant. Remember, also, we must keep the volumes constant. Same volumes, right? Range of substrate concentrations, again, we don't change the substrate concentrations by adding more of that solution. We change the substrate concentration by having different percentages or concentrations or molarities of that substrate, but we keep the same volumes, all right? So we must at some point mix enzyme and substrate. Unless we are investigating the enzyme concentration, we always must keep the enzyme concentration the same and the same volumes. And let's say we are investigating substrate concentration, that's our independent variable, and that's what we'll be changing. So we're going to have a range of substrate concentrations, okay? Then, whatever your enzyme is, and this will usually be explained to you in the question itself, you must have, and you must say how you are measuring product formation. How are you going to measure, how are you going to know that the reaction is happening, and how are you going to measure it? Okay, so this can be many things, right? And I'm just going to spell it out for you here, because, well, anyway. All right, so measuring product formation. Now, in some cases, you get gas, so your product is a gas. So for example, you know, the very common example, catalase, it produces oxygen gas when it reacts with the hydrogen peroxide. So our product is a gas, and so we will have to have some kind of mechanism, some kind of experimental setup to measure gas volume. Okay, so you should have done that experiment in class. If not, I've got a video on that. Please do check it out. Or you might have a color change. Okay, maybe your substrate is clear, but your product is green. That will be told to you in the in the intro of the question, and therefore, you know, what you're being told is, look, this is how you're going to measure your reaction. We want you to use this information. It might be a color change, so you're going to measure the color change. Possibly, you might, if that's the case, you'll have to use a colorimeter. Very important. Okay, so you're going to measure the intensity of the color, and that will give you an idea of how much of the product has been made. Okay, you're measuring product formation, or it might be that you're measuring the rate of disappearance of substrate. Okay. Or substrate disappearance. Either way, you will be told what change happens, what this enzyme does, and you've got to use that to measure. So the product might be a gas, there might be a color change. One question they love is pH changes. So when you break down lipids to fatty acids, it lowers the pH. And you know what you could do is, if you're measuring pH, maybe with a an electronic pH monitor or something like that, you can say that, oh, the more the pH decreases, the more the enzyme must be producing fatty acids from lipid. The more the enzyme must be breaking down the fatty acid to the lipid, and therefore the pH goes down. That's how I know that the reaction is happening. That's how I know that my product is forming, right? This is often missed out by students when they're answering the questions, and this is the key part of it, right? How can you measure whether an enzyme is working if you're not saying how it's forming the product, how it's actually working, what it's doing, and what you're going to be measuring? So there might be a pH change, color change, gas, pH. Yeah, can't think of anything else. I'm just going to put any other change that, oh, sorry, I forgot. Precipitates, right? When you've got liquid reactants and it forms a solid, i.e. in the Benedict's Benedict's reagent reacting with the reducing sugar, it forms that red precipitate. Precipitates, right? Now these are solid So you can actually collect precipitate and weigh them, right? Or if it's colored, again, bang, colorimeter, done. Okay, so colored things, use a colorimeter. If it's a change of state, you could possibly collect the precipitate and weigh it. Right, and the more precipitate that's formed, more product was formed. More product formed, rate of the enzyme activity was higher. Okay, so don't forget these things. These are the critical parts. Okay, so we've mixed our enzyme and substrate. We're changing our substrate concentrations. We're saying we're going to have a range of substrate concentrations, but we're saying we must keep the volume the same. Okay, then we're going to say how we are going to measure our product. How are we going to measure either the product formation or the disappearance of the substrate? Either way, we're measuring the progress of the reaction. We're measuring we're measuring the enzyme activity. Okay, so, and then the next thing is we've got to measure it over a certain amount of time. So we're going to measure whatever change is happening for fixed certain period of time. Usually 1 minute will be enough, but it might depend on the question that you're being asked. Okay, so measure for a certain period of time using stop clock. Okay, so if we are measuring gas volume, we don't just sit there and watch the gas collecting. Nope, we start our stop clock. We add the enzyme to the substrate, and then we look and see how much gas is collected in 1 minute. That's going to give us our graph. Because hopefully, the more active that enzyme is, maybe possibly because of more substrate concentration, increasing substrate concentration, we'll see that more gas is produced within that 1 minute as we increase substrate concentration. Okay, so we're going to measure for a certain period of time using stop clock, and we're going to see how much of this change has occurred. So measure these things for a certain period of time using the stop clock. Okay, and then I don't know if I'm running out of space, but the final thing would be to plot pH changes or volume of gas collected or precipitate collected. Plot data on a graph versus whatever independent variable you had. So in this case, it would be substrate concentration. Okay, right, I hope this is making sense. So, let's say I wanted to see what the effect of substrate concentration was on catalase. All right, so what I would do is I would have fixed concentrations of catalase, the hydrogen peroxide in the tubes. That's my substrate. So I would have a little bit of substrate here. I'd have a higher concentration there. I'd have a higher concentration there. I'd have a higher concentration there, and a higher concentration there. But the same volumes. I'm making sure that my experiment is valid. All right. So having the same volumes makes that valid, right? Then next, I need to add the same amount of concentration of enzyme and volume, right? Because I'm not looking at the effect of the enzyme, I'm only looking at the effect of substrate. So the enzyme is always the same, actually. So the enzyme is the same volume of enzyme. So the enzyme is not changing. Okay? So I mix my enzyme and different concentrations of substrate together, and I measure the amount of oxygen produced in a minute, and if I collect that data, I will have a nice graph that will look something like this if I've got the right concentrations. Okay, right. So on here I would have volume gas collected with units, centimeters cubed, and here I would have substrate concentrations, maybe percentages or maybe moles per decimeter cubed. Okay, this is very important. And don't forget that you're doing it in a fixed amount of time, right? Okay. Right. Other thing, controls. Right? You must make sure that at some point in your experiment you're proving that it's the enzyme that's doing the, carrying out the catalysis of the reaction. So you should always have a control tube which has substrate in it or whatever, and no enzyme, but maybe just an equivalent volume of water. Right? In which case you'll get no gas produced, possibly, hopefully, and that will show that it's the presence of the enzyme which is actually causing the breakdown of hydrogen peroxide to occur. All right, so main points: mix the enzyme and the substrate, mention what you're going to do to make your experiment valid, i.e. you're going to keep the enzyme concentration constant. Also other things. So don't forget your no enzyme control, because you need to compare, you need to prove that it's the enzyme that's actually making the, causing the gas to be produced. Secondly, you've got to control the other variables. So in this case, I'm changing the substrate concentration, so I must make sure that I'm controlling temperature. I'm controlling pH. pH can be controlled using buffers. Temperature can be controlled using thermostatically controlled water baths. Don't just say water baths. Okay, guys, right? Now remember, this could all be different. So I might be looking at a range of pHs, okay? In that case, I have to make sure that I'm not controlling my I know what my pHs are, but in this case, I don't control pH. Now I need to make sure that my substrate concentrations are all the same. So I'm no longer investigating that variable, I'm doing this one, okay? And if I'm investigating a range of different temperatures, then, again, I don't need to keep that constant, but I need to keep my pH constant. I hope this is making sense. If you're changing one variable, you've got to make sure that the other ones are the same or being kept constant. Okay, so mix the enzyme and substrate. Say what you're changing, say what you're keeping constant, say how you are going to know that the reaction is happening, and how are you actually going to measure that. Measuring the time is an essential part of that. So I'm going to measure the volume of gas collected in 1 minute, or I'm going to measure the extent or the precipitate that's formed in 1 minute, etc. Finally, by doing so, and then you're going to say what you're going to, the factors which you're going to control, mention your no enzyme control to confirm that it's the enzyme that's carrying out the reaction. And finally, you plot the data on a graph to see the effect of the no, whatever independent variable it was, on the enzyme controlled reaction. Okay? Right. Now, one caveat to this is the inhibitor or the cofactor. Now, when we're looking at inhibitors or cofactors, we don't just put a range of inhibitors, concentrations or a range of cofactor concentrations, we need to make a graph of substrate versus substrate concentrations versus product formed, and we got to have a fixed concentration of inhibitor or cofactor. That's the only difference. If we're investigating pH, range of pHs. If we're investigating substrate concentration, range of substrate concentrations. If we're investigating temperature, range of temperatures or increasing temperatures. But if we're investigating cofactors or inhibitors, we always have a range of substrate concentrations, and we are looking at the effect of a fixed amount of inhibitor or cofactor in this case. Okay, so this same concentration, same volume in each tube, it could be either a cofactor or it could be an inhibitor. So with cofactors or inhibitors, it's always a substrate concentration that we change, and we are looking for the effect of the inhibitor if it's present or absent, or the cofactor if it's present or absent. Okay? I foresee there being questions about this, so please put them down there in the comment section. And I will wish you good luck, guys. Keep working.